All right, good morning. I'm Betsy Mason. I'm a freelance journalist based here in the Bay Area. I'm also a board member of the Council for the Advancement of Science Writing, so I'm very happy to be able to welcome you all here to San Francisco and the World Conference. I'm also very pleased to introduce our plenary speaker this morning, Alberto Cairo. He's a professor at the University of Miami, where he's the Knight Chair in Visual Journalism and director of the Visualization Program at the Center for Computational Science. Before landing in academia, he ran the Infographics and multimedia operations for the magazine publisher Editora Globo in Brazil, and before that, he founded the interactive infographics department at El Mundo newspaper in Spain. And during his tenure there, his team won more international infographics awards than any other news organization worldwide. He's written 2 books about infographics and visualization, The Functional Art and The Truthful Art. He's taught classes and workshops in more than 20 countries over the last decade, and he continues to be a working journalist and a freelance designer for several companies. Somehow, on top of all of this, he's recently launched what he calls the Trumpery Tour, where he travels the world explaining how to spot and fight against fake data and visualizations. You can find the tour schedule on his website at thefunctionalart.com. Please welcome Alberto Cairo.
Thank you. Well, good morning, everyone. Thank you for being here. It's an honor to talk to you today about graphics and visualization and data. My purpose today is to convince you that doing visualization and doing infographics is within reach of anybody. We tend to believe, journalists who write tend to believe that creating visualization is hard, that it involves using advanced coding and programming languages. My purpose today is to convince you that if you keep just in mind a few principles and you pay attention to a few free tools that you can find online, you can start creating very effective visualizations that you can start including in your reporting or using to explore data and to discover things in the data. I have been teaching and doing graphics all my life. Betsy mentioned before my tenure at El Mundo in Spain. I was born in Spain, and I began my career in Spain back in 1997, producing mainly what we call in the news industry infographics, which are pictorial representations of information, visual explanations of how a spaceship works, right? And you do a 3D model of the spaceship, and then you animate it, and it explains the different components of that spaceship. I used to produce that kind of work. And more recently, I have started becoming more interested in another branch of the visual representation of information called data visualization, which consists of transforming numbers into graphs, maps, charts, etc., to extract meaning from those numbers. And that is what I will be focusing on today, data visualization. I am going to talk a little bit about tools and principles, right? About both. I'm going to quickly demonstrate a very easy to use data visualization tool in just 1 minute, and then later on I will talk about some principles that can guide your visualization work from this point on if I am successful at convincing you that all of you are able to produce visualizations. But obviously, it is not possible to cover everything you possibly want or need to learn about visualization in just 1 hour. Therefore, something that I'm going to do at the end of the presentation, and I'm going to do it live, is that I'm going to tweet that. That's the tweet that is ready on my Twitter account to be sent at the end of the presentation with all the hashtags pertaining to this conference. On that tweet, I will put, that's my Twitter account, Alberto Cairo. Even if you are not on Twitter, you can still see it. On that tweet, I will put the link. I will put a link to these slides, the slides that I'm using today, so you can access all the projects and examples that I will be showing. And I will also link to a Dropbox folder in which I have put several extra reading materials that expand on the contents and the principles that I will be explaining today. So let's get started. Let's first of all define visualization. In both my books, I use a very broad definition of visualization. For me, a visualization is any sort of visual representation, usually of data, that lets you explore those data, lets you extract meaning from those data, and lets you communicate those data in some way. the way that I explain this in my classes and lectures is that somehow visualization gives you superpowers because it lets you see beyond or behind the complexity of information by transforming that information into graphic forms. Data visualization is based on the idea, on the principle of visual encoding. This is the most fundamental principle of data visualization. You begin with a bunch of numbers, 22, 33, 44, whatever those numbers are. I'm listing several numbers down there. And then what you do is that you map those numbers onto properties of objects. So for instance, you begin with those 5 numbers, and then you get a bunch of bars, and you vary the length or the height of those bars in proportion to the numbers that you are representing. You can also vary the position of different objects over common axes. You can also vary the size of different objects, right, according to the numbers that are being represented. You can use the area, for example, of bubbles to represent data. You can use angle, like in a pie chart, to represent the proportions that you are intending to communicate. You can use line weight. You can use shade of color, for example. In data maps, we tend to use shade of color to represent the data. So all these are methods of encoding. Now, how to choose? Later on, I will give you a couple of ideas of how you can choose the most appropriate method of representation depending on what you want to show. But just to give you a specific example of the use of data visualization, which is pretty famous probably among this audience, let's suppose, for example, that you have a huge database of global temperatures from the year 1000 up to the year 2000, measured in Celsius degrees. And the database, besides showing you the actual records of global temperatures, you also have the margin of error in there, the standard deviations of the data, etc. So you have this huge data set. You take a look at it on the Excel spreadsheet, and you see nothing. If you're a normal human being like me, a normal journalist, you will not be able to extract any meaning from those data, right? But what about if you grab all those data and you map those numbers onto spatial properties of objects? For example, you transform those records of global temperatures from the year 1000 up to the year 2000 into some sort of line chart. Suddenly, you will have a very small chart that will condense all those data and will show you the reality that hid before behind all those data. This chart is commonly called the hockey stick chart, created in the years 1998 and 1999 by a group of environmental scientists. For example, Professor Michael Mann, who has a wonderful book about the chart and all the controversy around it, titled The Hockey Stick and the Climate Wars. I believe that's the title of the book. Anyway, so the chart is showing you, it's very, very simple to understand. On the x-axis, you have years. On the y-axis, you have temperatures in Celsius degrees in comparison to the average of the middle of the 20th century. So that's the 0 point. So whatever is up, it means that above that average, and whatever is down is below the average. And obviously, what you can, and then the blue line is the actual estimates of global temperatures. The black line is, so to speak, the overall trend of the data. And then the gray area behind is the level of uncertainty of the data, right? So year by year, you can notice immediately that this is a wonderful feature of data visualization, is that a feature that was hidden before when you saw the spreadsheet is that from the year 1000 up to the year 1900 or something like that, global temperatures stayed below that average from the 20th century. But then once we get to the beginning of the 20th century, because of CO2 emissions and increasing use of fossil fuels, etc., global temperatures started spiking up, creating that shape of a hockey stick. Right? So all the information that we had before in a huge spreadsheet that no normal being can understand, once you map it visually, then you can start seeing trends and patterns in the data. And that's the whole purpose of data visualization, to let you extract trends and patterns in the data. Now, data visualization is becoming mainstream, meaning that more and more people are starting to use it. It's becoming really popular in the media, etc., for many different reasons. I'm going to show you why the different reasons why I believe that more and more people are embracing it. Obviously, I'm very happy that that is happening because I teach visualization. So, well, the first reason, I believe, is the role of pioneers, people who popularized the use of data visualization among the general public. One example would be Professor Hans Rosling, who sadly passed away a few months ago. Hans Rosling used to be a professor of global health in the Karolinska Institute in Sweden. And his website is gapminder.org, and I would encourage you all to visit his website when you have the chance and take a look at the many lectures that he delivered throughout the years in which he combined a very enthusiastic style of speech or speaking with the use of data visualizations. And it was a wonderful, wonderful, wonderful presenter. He was always using graphics and always using data. And he became really, really famous after he gave a TED Talk in 2006, and he became a global celebrity. Another factor that also contributes, I believe, to the popularization of data visualization is the increased use in the media. So newspapers, magazines, news organizations such as the Wall Street Journal, the New York Times, the Washington Post, the LA Times, and so on and so forth, Vox.com, 538, all these organizations are using data visualization more and more. And it has been proven that in many cases, some of the most popular stories that some of these organizations have published online in the past decade or so are actually data visualizations. The public really likes graphics if they are well done, well designed, and they are beautifully presented. Data visualization is also increasingly recognized as a core part of journalism, and it has started winning even Pulitzer Awards. So I believe that it was in 2015, the Washington Post, for example, won a Pulitzer Award thanks to a data visualization showing you how many people died during police shootings, right? Another Pulitzer Award, also given to a data visualization, went more locally in Florida, I live in Miami, went to the Tampa Bay Times, which won a Pulitzer Award, I believe for public service, thanks to an amazing project called Failure Factories, which talks about how certain school districts in the Tampa area are becoming increasingly racially segregated, and as a result of that, the performance of the school performance of some of these districts is also going down. And most of the project, a core part of the project, is a wonderful data visualization that the Tampa Bay Times created. Now, when we see all these examples in the media, when you see all these examples in the media, all of them look very complex, they look very sophisticated. In many cases, they are created using programming tools, right? So in many cases, all of these projects are done, for example, with HTML, CSS, JavaScript, a JavaScript library called D3. All these tools have a slightly steep learning curve, right? And some people believe that that's basically a hurdle, that is a wall that impedes you from beginning to do data visualization and incorporate it to your reporting or to your stories. And what I like to point out during my classes and during my talks is that certainly if you learn how to code, that's wonderful. If you learn how to use JavaScript or I don't know, the R programming language, which is a programming language that I use to explore data, all that is wonderful. But that comes after you do something else, which is to begin playing with tools that enable you to create data visualization very quickly and very easily and experimenting with them. And then later on, then you can learn JavaScript and D3 and all that stuff. But the first step is to get familiarized, to get acquainted with some of these tools. Therefore, right after the presentation, when you have access to all these slides, this slide links to a series of tutorials, video tutorials, that I have recorded throughout the years, teaching how to use some of these tools. All the tutorials that you will find through that link are completely free. Those are the tutorials that I use in my own classes at the University of Miami to teach students, for example, how to use basic Excel, right? How to do a pivot table in Excel, something like that. Excel is not free, obviously, but it's widely available. And then I teach tools such as Insight, which is a wonderful data visualization tool for data exploration. That one is completely free and open source. I have tutorials about Quantum GIS, which is a mapping tool that is also free and open source. Tutorials about Adobe Illustrator, which is not a free tool, but is widely available in newsrooms. Every single designer I know of uses Adobe Illustrator for one purpose or another. So basically, I teach you in those free tutorials how to use some of these tools. And I guarantee that most of them doesn't take more than 1 hour and a couple of hours to start grasping how it works and how you can start incorporating the results to your own reporting. Now, there is one in particular that can be demonstrated in just a couple of minutes, a free tool called RAW, or raw graphs that you can find online. This works on the browser. This is a tool that was created by an Italian visualization lab in the Politecnico di Milano, and they made it freely available for everybody, for all of you. I'm going to just demonstrate very quickly how RAW works, just to show you how easy it is to create a simple visualization. So this is RAW, all right? And once you click on Create a Chart, it will open up this window in which this is completely idiot-proof because it says copy and paste the data here. Okay, let's do that. So I have an Excel spreadsheet over here. This Excel spreadsheet over here. These are tons of different metrics from all countries in the world, things such as life expectancy, and children per woman, GDP per capita, tons of different metrics downloaded from the World Bank. So I'm going to get all this data, copy all of it, go to RAW, and I'm going to paste it here. You can also upload the file if you want, right? But I'm going to paste the data in there. It's going to process the data. Once it finishes, you will get a green light saying, ready to go. So let's do something. I'm going to scroll down and say, all right, so I am going to see whether there is a relationship between, for example, I don't know, children per woman and child mortality, country by country, right? So I'm going to do a scatter plot. Scatter plot is a great way of showing the relationship between two variables. I'm going to scroll down. I have already selected the scatter plot, although you can see that you can create tons of different kinds of graphs, pie charts, line charts, scatter plots, bubble charts. You can create tons of different kinds of visualizations with RAW. And over here, RAW is telling you, map your dimensions, which translated to common language means drop the variables here. All right, so I'm going to say, all right, so let me see if I can find over here children per woman. So I'm going to get children per woman and put children per woman on the x-axis. Then I'm going to get infant mortality, which is over here, and I'm going to drop infant mortality over here. And then I'm going to scroll down just to take a quick look at the results. So you can see that there's a scatter plot in there already, showing that basically there is a relationship, right? The bigger the child mortality, the bigger the number of children per woman, right? But the chart doesn't look great so far. Let's do something else with it. So we can do more things. For example, we could change the size of each one of these bubbles according to the population of each one of these countries. So I'm going to do that. I'm going to scroll up and try to find population total, right, which is over here. Let me see if I can see it over there. Population total is this one over here. I'm going to just drag it over here, size, and I'm going to scroll down and see what it has done. So it has scaled the bubbles according to the population of each one of these countries, right? Now, let's do something else. I also have another variable called region, which is similar to continent. It's not the same. I don't have the continents here, but I have the region, like South Asia, North Asia, and so on and so forth. I'm going to drop the region on color because I want each one of those bubbles to be colored according to the region they belong to, right? So I'm going to drop it over here. And let's scroll down and see what happens. Each one of them has been colored according to the region they belong to. This is the color scheme, okay? This is the legend. Right? And we could do more things, right? I could go over here and say, all right, let's label the countries. That's going to make the graphic look a little bit messy, but it may be helpful if you want to spot specific countries and then remove the labels, right? So I'm going to drop countries on label, and then I'm going to scroll down, and all the labels are going to be positioned next to the corresponding, next to the corresponding bubble. Now, the wonderful thing, I'm going to remove the labels for now because it's a little bit messy. Now, the wonderful thing about tools like RAW is that once you have finished, you can either download the results, right, as an SVG, which is a vector file, so you can export it and then open it up in Adobe Illustrator or other many tools and style it further. Or if you don't want to do any of that, you can just style it in the tool, generate the HTML and SVG code, right? That's a little bit of a jargon, but basically it generates code that you can copy and paste in your own website, and the chart will appear within your own story. Boom, you have your first visualization in just 1 minute. How wonderful is that? So some of the tools that I explore and that I explain in in those video tutorials that I have mentioned to you are as easy as raw. So the tools are not a problem. The tools are available out there if you want to get started, okay? If you want to start exploring these things. But tools are not enough. And tools are just a portion of what we need to pay attention at if we want to become good at creating data visualizations. So the second part, which is much more important than the tools themselves, is the principles that should guide the creation of any data visualization. So I'm going to spell out a little bit some of the principles that I follow and that I try to teach in my classes. I usually joke with my students that throughout my career I probably have written more than 1,000 pages about principles of data visualization and stuff, right? Books and articles and blog posts, etc., etc. But, you know, I am a journalist. I like to be concise, and I believe that it is possible to condense those thousands of pages into 4 principles. So let's talk about those 4 principles of data visualization. A good graphic, a good visualization needs to be based on good data. That's the first principle. It sounds very obvious, but it is not. I will show you a couple of examples of what I mean in just 1 second. The second principle is that a good visualization that you insert in any story needs to look good, all right? You should not just get Excel, create an Excel chart, not doing any further styling, and then just copy and paste it in your story, because the default options of most software tools are really terrible. You need to change the style of that chart to make it look good. Charts need to look elegant. The same way that you pay attention at the style, at your writing style when you write, we also need to pay attention at typography, color, composition, certain very basic rules of graphic design whenever we do visualization. The third principle is that a good graphic represents the data accurately, and the fourth principle is that a good graphic needs to show an amount of data that is enough for readers to figure out what's going on, right? The last principle is my favorite one, because I am obviously a journalist, and I talk to journalists every day and to graphic designers. And we journalists tend to believe that data visualization is all about simplification. Nobody likes to read anymore. Let's simplify this data. Let's get this data and create a simple representation of data. I don't like to talk about simplification. I don't like to talk about to simplify things. I like to talk about clarification. And in order to clarify, sometimes you need to increase the amount of data that you show rather than decrease the amount of data that you show. I will show you examples of the 4 principles. Let's get started. A good graphic is based on good data, right? And when we see a graphic in the media, for example, perhaps we should pay attention to where the data comes from, how the data was generated, and what it is that is being measured. Betsy, at the beginning of the presentation, said that I'm doing a series of lectures all over the country titled Visual Trumpery, and I'm not going to explain where the title comes from, but it has nothing to do with politics, by the way. I'm not kidding about it, nothing to do with politics. But anyway, so in these talks, I try to explain people these principles through very simple and basic examples and stories. So let me begin with a very simple example that illustrates this idea really well. A while ago, I saw a map in social media that I absolutely loved, and I immediately retweeted it. I shouldn't have done that, because we should never retweet anything without verifying whether that map is showing the right information. It is this map over here. Concentration of heavy metal bands in Europe, okay? So it's number of heavy metal bands per million people all over Europe. Now, I love this map because it actually represents something that I already know, which is that there is an inverse correlation between number of heavy metal bands and number of hours of daylight, country by country. So the darker a place gets, the more heavy metal bands you have. So if you go to Spain, for example, we have some heavy metal bands over there, which are actually quite good. But in Spain, we have 10% the rate as in Finland, which is the heavy metal capital of the world. And not only that, actually, in Finland, you not only have tons of heavy metal bands, you also have the heaviest heavy metal bands. Like you have branches of heavy metal called doom metal and death metal and things like that, right? Things that I don't really enjoy that much. I happen to like heavy metal and hard rock, but not to those extremes, right? Anyway, so I saw the map, I loved it. It confirmed something that I already knew. I retweeted it. But then I thought twice. I said, well, wait a second. Is this counting the right thing? What is the source of the information? And is the source counting only heavy metal bands? Let me explain what I mean. So in just 1 second. So I went to the source. Fortunately, the creator of the map indicates what the source is. It's a website called Encyclopedia Metallum. So before going to the source, though, and verifying the data before retweeting the map again, I tried to think about the average. Right? The most representative heavy metal band, right? Just to use that as an average. Just thinking about if all the bands in this data set are similar to this particular band that basically has all the quintessential features of a heavy metal band, then the data source is right. But then if they are counting other kinds of bands, perhaps this is not a very reliable source. So it is useful, before going to the source, at least it was for me, to try to imagine what is the most quintessential heavy metal band. Being here in America, probably you have bands like Metallica in mind, right? If you're from Europe and you are older, perhaps you remember Black Sabbath, for example, and bands like that. Well, I'm a little bit younger, so I grew up during the 80s, and for me, the most quintessential heavy metal band, the one that has all the features, all of them that are usually related to heavy metal bands, is Judas Priest. I mean, Judas Priest has all that is metal about heavy metal, everything. It's like the long hair, except the singer who is bald, but the other guys in the band, they all have long hair. They have the leather jackets, the skinny leather pants, and then obviously they play. They have heavy guitars and thundering drums, and the songs that they sing are super goofy in terms of lyrics, like the songs about demons and monsters and things like that, right? They don't sing that much. They scream a lot, so that's also very heavy metal. So it's like they have all these features that we commonly associate with heavy metal, right? So the way to think about the data source is that if all the bands that are counted in this data set are more similar than not to Judas Priest, then the source is reliable. That is the first step to verify any source, right? But being familiar with the academic and non-academic literature about heavy metal, having read books about the history of heavy metal, having read magazines about heavy metal in my life, etc., 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 I have seen also other kinds of bands also being labeled as heavy metal, and that is not heavy metal. So, Bon Jovi is a perfectly fine band. They have good songs and bad songs, good albums, bad albums, but it's certainly not heavy metal. But I have seen them labeled as heavy metal. So I went to the source, I checked for the presence or non-presence of some of these bands that I saw labeled as heavy metal. Bon Jovi is not there, great. I also checked for other bands that I have also seen being labeled as heavy metal, such as Foreigner. Remember Foreigner from the 80s? Journey. You remember Journey? I have seen Journey labeled as heavy metal. Come on, that's not heavy metal. Anyway, so I checked for all those bands. They are not there. All the bands that are listed in the source, all of them are pure heavy metal. Pure heavy metal. Now, I cannot claim that this source is completely reliable, but at least I have verified that they are counting only bands that are heavy metal. Then I retweet the map, right? Now, this is a goofy, very silly example, which is really, really helpful, I believe, to explain the general public how they can verify sources themselves, which is something that any person can do. Let me show you an example that is a little bit more serious and perhaps will sound a little bit, a little bit more useful for you. In my second book, The Truthful Art, I describe several examples that I borrow from several friends. I have many friends who work in the work of statistics, One of them, Heather Cross, she is a statistician from Canada who works for non-governmental organizations, helping these organizations understand their data better and manage their data, explore their data, etc. And she once shared with me this story. She was doing some exploration about intimate partner violence rates, violence within families, right? And she discovered that depending on the source that you consult, the rates vary a lot, and that is what these graphs are representing. So focus, for example, on the bars corresponding to Cameroon, okay, Cameroon. The rates are over here, that's the y-axis, that's the rate of intimate partner violence, IPV, and each one of the bars, each one of the blue bars corresponds to the IPV reported by a source. So you have source number 1, source number 2, source number 3, source number 4. Now, why do they differ so much, right? Because they differ very, very much. And obviously, you will only discover that if you read the methodology from each one of these sources, because they are using the name IPV to refer to different things. In some cases, you have a source that is counting only physical violence. Therefore, the rate is really low. Other sources are also counting verbal violence. Therefore, the rate appears enormous. Now, how many times have you seen people comparing data from different sources without checking the methodology of both sources to see whether they are comparing apple to oranges? It happens all the time. And obviously, we need to be really, really careful. So the first principle that I listed before, making sure that you're using reliable data, happens before you even create any sort of graph, before you even open up any tool to create a data visualization. We need to talk to sources, we need to talk to experts. None of us is an expert on statistics, so we need to talk to statisticians. Perhaps this sounds as a platitude because you all do that, right? But we need to, I believe, to keep reminding ourselves how important it is not to rush, download a data set and represent it immediately, right? We need to stop and first of all verify all those data. Now let me jump to the fourth principle, right, which is related also to the first one, showing the right amount of data. This is what I mean, and it is related to that principle of never simplify, clarify instead. Let me show you a graphic that is mathematically fine, right, but it's a simplification of data. So this is a chart, a table that shows the unemployment rate in the United States in the first 3 months of each one of these presidencies. So, or the average unemployment rate. So under President Obama, for example, in the first 100 days of his tenure, the unemployment rate, the average unemployment rate was 9.0. Under President Bush, it was 4.4. Under President Clinton, it was 7.1. The numbers are perfectly fine, the numbers are correct, but this is an oversimplification. And it is what happened. You may think that this is politically motivated. I don't know if it is. And I don't care, because I have seen people with the best of intentions in newsrooms make the same mistake, show only a couple of data points to make a point with forgetting the context of those data. Compared to what? Compared to whom? Right? We sometimes tend to oversimplify the information that we present to people. And this is one of these cases in which increasing the amount of data that we show may clarify the story. Because if you think critically about these numbers, you probably know, you probably have guessed that the unemployment rate in the first 3 months of any presidency is largely an effect of what you inherited from the previous guy, right? So that's what's happening over here. So a more clarifying representation of information would be not to show just that number, but to show, for example, the unemployment rate on January at the beginning of each tenure and on December at the end of each tenure. The beginning at the end, the beginning at the end, the beginning at the end. When you do that, the story obviously changes completely, right? So at the beginning of each presidency, we have that number. At the end of each presidency, we have that number. And then we show the change in percentage points. So please, please forget about that journalism and data visualization is about simplifying things. It's about clarifying things. Only show the data that you need to show, but never oversimplify the data. Always think about compared to what? What is the baseline? What is the base rate? What is the beginning? What is the end? Compared to the average. All those kinds of comparisons are incredibly valuable. Another important thing to remember, right, related to this principle of showing enough amount of information is that a chart always shows as much as it hides. Let me show you what I mean by this. This is an example that comes from a wonderful book that I recommend to everybody, titled Teaching Statistics, A Bag of Tricks. This is the example by Andrew Gelman and Deborah Nolan. So this is a map that shows you the lowest kidney cancer death rates in the United States in the 80s, right, between 1980 and 1981. You see that map, you see those counties, and I'm going to give you another small piece of information over here, which is described in the book, which is that most of those counties over there are rural counties. Now, I can guarantee that if you show that map to most people and you tell them, these are the lowest rates, most of these counties are rural, people will start making up stories in their minds. And this happens to all of us. We start extracting inferences from the map. I'm going to just word some of the inferences that came to my mind before I knew better. Okay, so those are the lowest death rates. All those counties are rural. So let me see. Okay, they're rural, so probably people there exercise more. They probably walk more, etc. They probably eat better because they grow their own food, so they eat organic. That could be. Perhaps they have a stronger family ties just because they live in a rural environment, and we know that all these factors contribute to getting better when you have cancer, to recover more when you have cancer, or not developing cancer in the first place. If you eat better and if you exercise more, those are factors that contribute to having lowest cancer rates and therefore lowest death rates of cancer, right? So rural, low cancer rates. All that obviously is wrong, because if you take a look at the highest cancer mortality rates, most of those happen in rural counties as well. All the counties, or most of the counties that have the highest mortality rates of cancer are also rural. What's going on over here? Well, this is a basic fact of statistics, right? Which is that low or small samples or small populations tend to vary much more than big samples and big populations. Let me do an infographic for you. I have a hard time visualizing numbers, so I usually like to represent them graphically. So let me use my fingers. Imagine that you have a county in which only 10 people live, right? And in one decade, one of those 10 people dies of cancer. Suddenly, you have a huge rate of death of cancer, 10%. One person out of 10%, 10% of people in that county are dying of cancer. Therefore, that particular county will end up on the highest death rate, mortality rate, on the second map in one decade. But then on the decade after that, on that same county, nobody dies. Therefore, you have a zero cancer death rate. Therefore, that same county will end up on the other map, on the first map over there, the lowest mortality rate. So here what we are witnessing has nothing to do with eating anything or exercising more. It's just a sheer effect of the natural variation of data. Becoming aware of these very little facts of statistics doesn't require any sort of formal training. It is just a matter of reading about them and then becoming more cognizant about them. Another example of oversimplification through a chart that is perfectly fine, nothing wrong with it. The chart is perfectly fine, it's showing real data. The US murder rate. So as you know, the US murder rate, the murder rate in this country per 100,000 people went up during the 80s, right? Very sharply. Then it went down also very sharply during the 90s and the 2000s. And then in the past couple of years, that murder rate has increased in this country, right? There is nothing wrong with that chart. This is all based on solid data, murder rate all over the country. But as I mentioned before, a chart always shows as much as it hides. And if you only use this chart, you're doing a disservice to your readers. Why? Because that chart is showing you the murder rate all over the United States. It's aggregating all the murders all over the country. And that increase that you're seeing over there is largely an effect of certain neighborhoods of certain cities like Baltimore, Chicago, Miami, Milwaukee, etc. So if you want to visualize these, imagine that you have On the y-axis, the current murder rates in 2016, with each neighborhood of each city represented with a little dot, and the position on the y-axis corresponding to the murder rate of that particular area. Most of the neighborhoods in most of the cities of the United States, the murder rate is quite low. They are down here. But then suddenly you have 10, 20, I don't know how many, neighborhoods in the United States in which the murder rate is so enormous. So many people are dying in shootings and clashes with the police, etc. Well, not clashes with the police because it's the murder rate, but no, it's not death rate. So they're killing each other in such a high rate. They are out here that they are pushing the line up. Therefore, whenever we present a story like this to readers, in order to explain this story correctly, we should never, I believe, this is just my opinion, we should never use just that chart, because we need to talk about both the trend in the data and the outliers that may be skewing the trend in the data. Both pieces of information are fundamental to inform people about what is going on with these data. We need to present both. And it is better if we present both of them graphically. So we have the trend first, and then perhaps we can have smaller charts below showing you the murder rate in these particular neighborhoods that are so dangerous in the United States that are skewing the average murder rate in the United States. So let's now simplify from this point on. Let's clarify by increasing the amount of information just a little bit to provide more context. Then, a visualization needs to grab your attention, it needs to be eye-catching, but at the same time it needs to represent data accurately. Both of those two things go hand in hand. They are related to each other because there are graphics out there that are extremely eye-catching, very powerful visually, but they end up being misleading because they are not representing the data correctly. Now, let me show you a graph that was used in Congress a number of years ago to attack Planned Parenthood over here. So this chart, I don't really care what you think about Planned Parenthood. I don't really care whether you are against abortion or in favor of abortion. That's besides the point. What we really need to care about is not being lied to when we see graphs and we see charts. And this graph is a damn lie. Now, this graph over here is showing you the number of cancer screening procedures going down very sharply, and the number of abortion procedures going up very sharply at the same rate, creating the shape of an X, right? Most people take a look at the pattern of increase and of decrease, and they don't go beyond that, right? And the problem, oops, I don't know what's going on over here. Oh, give me a second. Oh, there you go, we are back. So, they don't read the numbers, they just take a look at the pattern, right? But when you read the numbers, which are super tiny for obvious reasons, you will see that it goes from 2-point-something million procedures down to 1 million procedures, but this one goes from 300,000 procedures up to 320,000 procedures. Therefore, the rate of change is just a little bit different, right? Now, that's how the chart looks like if you put everything on the same scale. Now, moreover, this chart is not just wrong because it's misrepresenting the real scale of the data, but also it's because it's hiding a lot of very relevant data. Because these are not the only things that Planned Parenthood does, right? They do also STD testing, for example, which is not contemplated on this chart. So designer Emily Shook created this chart showing you all the things that Planned Parenthood does, including STD screening, cancer screening, etc., etc., and abortions. Abortions is a line that is flat. So the original chart was completely wrong. This other chart over here is much better because it represents the data accurately and it includes the right amount of information. Now, let me show you another chart. When I use, by the way, the word chart, I may refer to maps and graphs and different kinds of things, right? Chart is like my generic word to refer to different kinds of visual representations. So another chart that misleads a lot of people, apparently, this is a map that hangs on the walls of the White House at the moment. So a reporter shot that picture in the White House. As you know, well, this is a choropleth map, a map that represents the results of the 2016 presidential elections using color as method of encoding, right? Red for the Republican Party, blue for the Democratic Party. President Trump is very fond of this map, and for a while, according to reports by Reuters, he printed out copies of the map and handed them out to reporters who came visit him to the Oval Office. That is photoshopped, by the way, but it is reflective of what actually happened for a while. he's apparently he's very proud of his victory, and I would say that he should be. He won against all odds, right? But what I would tell President Trump, if I could do a workshop in the White House, for example, I offer myself, by the way, openly on social media, say, I go to the White House, I do a one-day workshop for you, teaching you basic principles of data visualization. I will not charge anything, because I do believe that you're being misled by this map. And let me explain why. Well, by the way, supporters of President Trump love this map, so that map has appeared in several right-wing publications. It has also appeared on book covers. So this is an ebook that was recently published, written by author Jack Posobiec, a right-wing author, titled Citizens for Trump. I like to always offer my free advice on social media and constructive advice. And when I saw that on social media, I replied to Jack Posobiec saying, there is something wrong in your book. So the title doesn't really correspond to the map. Because, I believe that you either change the title or you change the map. I am aware that changing the map may be difficult because you need to learn how to use mapping tools, and that may take a while, although I can provide free resources to do that. I didn't say that, but the resources are there. So anyway, you either change the map or you change the title, because this map is not showing Citizens for Trump. So perhaps you should change the title of the book to Counties for Trump, because this map is representing counties. It's not representing people. If the sheer idea, if the basic idea of data visualization is the proportional representation of underlying numbers, the results of the presidential election were 46%, 48%. This map is representing a 90%, 10% split, because it is counting counties, counting territory, rather than counting people. So instead of using that map, perhaps some liberal commentators prefer to use this other map, which is a map that represents exactly the same thing, who won where, but then each one of the dots is scaled according to the number of voters on each one of these counties, right? So in each one of the counties. So right now you have more or less, proportionally, more or less the same amount of blue as you have as the amount of red. Is more proportional. Let me tell you, the preference for maps, I follow people who are conservative, people who are liberal in social media, and the preference in terms of maps is, there's a clear divide, ideological divide in there. So conservatives love the first map for obvious reasons. It looks like a landslide, right? And liberals tend to prefer the second map. Let me tell you, I think that both of them are wrong. Because in a presidential election in the United States, neither territory nor people matter that much. What really matters is the number of electoral votes that you have won. Therefore, the first thing that you need to show in any story that talks about the results of the presidential election will be some sort of chart, like a simple, humble pie chart that shows you how many electoral votes each one of the candidates got. And perhaps you can use a map, for example, that is called a cartogram. A cartogram is a map that distorts the size of different areas according to some sort of metric. For example, the number of electoral votes, right? In that case, you can get a clearer idea of the number of electoral votes that each one of the candidates won. So I would say to President Trump that instead of hanging that map over there, perhaps he could do, I would prefer to see a map like the one down there below, or just the pie chart. The pie chart is enough. If you only care about who won and by what margin, because that's a metric that really matters. All the maps are right, proportionally, not proportionally, but all the maps are mathematically right? But the interpretation that you extract from those maps is completely different. Maps can really mislead you. Let me show you, by the way, another example of map that misleads. So I don't know if you have heard that for a while, singer Kid Rock thought about running for the Senate for Michigan, right? I know basically nothing about this guy, but I heard that he was running for the Senate. He recently said that he was joking when he was announcing his candidacy. I don't think that that's the case, because there's a website that says Kid Rock for Senate or something like that, etc., etc. He announced it in some of his shows. I don't really care. So as I said before, what I really care about is charts, good charts, right? So on social media one day, I saw the t-shirts that Kid Rock is selling in his online store. I'm going to show you just one of them, because it is a map of the results of the presidential elections. Just your regular map, who won on each state. It's this t-shirt over here, red and blue. And the labeling will show you that the map is actually intended to represent the boundaries between the United States of America, red, and a country called Pakistan, which is blue. So the map, I believe, can be critiqued because if you really want to accurately represent the boundaries between the United States of America and Pakistan, doing it at the state level is not good. Why is it not good? Just focus on Florida, right? I live in Florida, right? And it looks like it's the United States of America. And I can tell you that where I live, South Florida, right, Miami, according to the label of this map, is not the United States of America. It is Pakistan. And people down there are pretty proud of their heritage down there. So anyway, before I finish today, I would like to talk a little bit about how to choose graphic forms, right? Once you open up one of these tools that I mentioned before, how do you decide how to encode the data? Obviously, I cannot go very deeply into these. There's more advice in the extra readings that I'm providing in that Dropbox folder that I mentioned before and that I will tweet about in just 1 second. But there are certain principles that you can follow in order to encode your data well. Should you use length? Should you use height? Should you use area? Should you use angle? Should you use color? How do you know? The first thing that you need to do whenever you are going to do any sort of visualization is to ask yourself, what is this for? That's the first thing. What is it that you want to enable? A visualization is not just a pretty picture. A visualization is a tool for understanding. It is a tool to do certain things with data. Sometimes you want people to compare things. Sometimes you want people to see patterns over a geographic area. There are specific graphic forms that are more appropriate than others for each one of these tasks. Imagine, for example, that you're doing a story about the unemployment rate in the United States. What is it that you want to show in the graphic? Do you care about geographic patterns in terms of unemployment rate? Then do a map. Do you want people to be able to rank the states or the counties of the United States according to, I think that I clicked on something or did something, oh, there we go. Do you want people to rank the counties or the states of the United States according to unemployment rates? Don't do a map, because a map will not let you see the first country, the second country, or the third country. It is better to do some sort of bar graph. Let me see what's going on with this projection. There you go, it's back. So what are the tasks that you want to enable? According to that, choose your graphic form. In order to help you with that process, there are a couple of websites that can provide some guidance. The Data Visualization Catalog and then N.K. Amery's website. Both of them are very similar. They are just catalogs of graphic forms. Each one of those icons, each one of those pictures will take, if you click on them, will take you to a short article about how and when to use a bar graph, how and when to use a map, how and when to use a histogram, and so on and so forth. So they are great starting points to decide which method of encoding you should use. Myself, I use those resources obviously, and many others, some of them in the Dropbox folder, but I also keep in mind a very basic principle, and you can start off with this very basic principle. In general, if you think about the methods of encoding such as length, height, or position over common axis, those are the kinds of graphs or charts that better enable accuracy. So whenever you want people to accurately compare things, or accurately see the relationship between two variables, or accurately see the variation of a particular metric, always use methods of encoding such as position, length, height, measure over common axis. Don't use other methods of encoding in general. Now, the other methods of encoding, such as height or color, etc., they may be useful in other circumstances, when what matters is not so much accuracy as providing a big picture of the data, right? So for instance, take a look at these series of maps by the New York Times, published after the 2008 election, right? The first map that you have over there uses area to encode the data. who won where and by what margin. The size of the bubble is proportional to the margin, either in favor of the Democratic candidate or in favor of the Republican Party. The purpose of that map is not to let you compare or to rank the cities according to a specific vote. It's to give you the big picture, where Democratic vote tends to concentrate, where Republican vote tends to concentrate. So it works really well to give you just the big picture of the data, but it is not great for accuracy. If you wanted to rank each one of the counties according to Democratic vote or Republican vote, you would need to create a completely different data visualization, perhaps a bar graph, a ranking with a bar attached to it. First country, second country, third country, etc. So it's also important, it's always important to remember what the graphic is for. Let me show you a specific example, just to finish the presentation today. It's an example that comes also from my second book. It's completely fictional. All right, but it is very similar to many graphics that I have seen in the media, among clients, etc., etc. Let's suppose that you conduct a survey at the University of Miami, where I teach, and you ask, in 1994, you do the first survey, and you ask a sample of 1,000 students what is their preferred music style. So if you ask them, if you must just choose one music style, one music genre that is of your preference, what would that be? And in 1994, you get the results on the first pie chart over here. This is obviously not true. As I mentioned before, I am a huge fan of this music genre, so I am assuming that most of the students are like me, which is not true. So more than one third of the students say that they like hard rock. 20-something% of the students, they say that they like samba, 20% say that they like hip hop, 10% reggaeton, which is a music style very popular in the area of Miami, comes from Puerto Rico, and then 5% country and classic music. So this is showing you the distribution, right? Among the 1,000 students, which percentage of them likes each one of these music styles more than they like the other music styles. So it looks fine, right? Now, you conduct exactly the same survey in 2014, and you get these results, okay? And I have hidden the numbers. Why? Because a visualization should be something that lets you do things with the data without having to read every single number in the figure. If you need to read every single number in order to be able to compare one year to another year, you're doing something wrong. Now, let's do something with the data. The whole purpose of this graphic, by the way, is explicit in the title. The title of the chart is telling you what this chart is for, how music preferences have changed over the years. That's the purpose of the graphic, to show change. So you need to choose your graphic form according to the purpose of the graphic, right? So let's try to fulfill that purpose. Has hard rock become more or less popular between 1994 and 2014? More, right? Go Judas Priest. It's becoming more popular. Now, what about samba? Is samba more or less popular? That's harder, right? It's harder to do. You need to squint a little bit, perhaps use your fingers, right, to compare the segments of the chart. Not very efficient. Now, what about hip hop? Difficult to tell. What about reggaeton? It's more or less popular. Difficult to tell. Why? Because the pie chart is not a graphic that is intended to show change accurately. Remember what I said before, when you want accuracy, you need graphics that are measured over common axes. The method of encoding in a pie chart is angle and area, and those things are not very good for accuracy. They may be good for the big picture, more or less, but no more than that. Therefore, if what you want to show is change with accuracy, show change. Perhaps with some sort of line chart that shows you one genre going up, one genre going down, and so on and so forth. So by all means, after the lecture today, take all the tools that I mentioned at the beginning of the presentation, but please, please pay attention to these very, very basic principles. And now what I'm going to do, we have 15 minutes for questions, I believe, so I will take some questions. And while I wait for your questions, I'm going to tweet that, so all of you will have access to the slides and to the extra materials. Thank you so much for coming. There goes the tweet. All right, questions? Yes.
Thank you for mentioning Hans. I was at that lecture.
Oh, you were?
I did not know that he'd passed. An amazing, eye-opening thing. Let me go to a question that has an ethical and a practical component. The ethical component is, should we be persuasive? That's an argument for your organization and its mission. Let's assume then that we have a mission and an organization that wants to be not merely informative, but persuasive.
Yeah.
I want to ask you whether you believe that adding motion and music to visualizations to make them animations achieves that purpose. And the thing that put this in my head, I don't have a lot of experience making them. I have not had the ability or the occasion to, but I want to. I saw something called The Fallen of World War II. It's about 16 minutes, and
Yes.
it shows, have you seen this one?
Yes, I have
For
seen
those
it.
who haven't, it's like a bar graph, and Americans dying, French dying, Germans dying, and then Russians dying. And you're forced to watch the bar spool out,
Accumulating, yeah, and growing.
which hits you in the face and says, they died more. Is that a technique that is might be on one of your catalogs?
Yeah. Well,
Is
it
it
is part
effective
of
and is-
principle number 2. Remember what it's part of principle number 2, attract people's attention. So it's related to that. I think that those kinds of techniques are appropriate. So I interrupted you. You wanted to follow up.
So you tell us the techniques that you think could add a static image gives you information. How do we add persuasiveness
Yeah.
if we have the mandate to do so?
Yeah, so I think that it is appropriate to try to persuade people of the reality of what the chart is showing. I think that it is appropriate. And you can try to introduce a little bit of emotion in your charts and your animations and graphs, etc. Don't go overboard with that, but it is the same way that you try to introduce emotions in your writing, talking about specific people and how people are affected by scientific discoveries or whatever it is that you're writing. The same way, I believe something similar could be done in graphics, through the headline of the graphic, through the introduction of the graphic, through the colors that you use in the graphic, through the animation that you put in there. But obviously, the first thing that we need to care about before we do that is being truthful and being sure that the data that we're showing actually merits that emotional representation, right? The emotional representation is something that you can use to attract people's attention to the data. But then what really matters is to show them the evidence of the data. So both things go hand in hand. I think that is perfectly appropriate, if it is well used, obviously. Yeah.
Hi, I work at the Exploratorium, and one of my jobs is to curate data visualizations for the public. We have a big media wall and we show them. And I'm really wondering if you've done much work in visual literacy, how people really cognitively understand graphs, because for one instance is that I think quite a while ago there was some studies about whether people can read time series graphs, just X, Y axis. And it showed that they weren't good at it. But we've recently tested people and found that people, at least coming to the Exploratorium, are getting better at it. So
Yep.
I'm wondering if you've done some work on,
Yep.
on visual literacy.
So, all right, so the entire, that lecture series that I am doing, Visual Trumpery, the original title of the talk was Graphicacy, which is graphic literacy, right? So it's all about that, about how we can become more knowledgeable in reading graphics. The point that I make at the beginning of the presentation, obviously, is that if I use a title like Graphicacy, my audience will be half the size of what it is by calling it Visual Trumpery. So I'm tricking people into coming to my talk. Anyway, so I talk a little bit about that, and actually one of the examples that I show, let me see if I can bring up a slide and show it to you. So I don't know if you heard, for example, it's completely related to your question. The Pew Research Center in 2014 tested a sample of people, I think that it was like 1,000 people or something like that. They showed them that a scatter plot, which shows the relationship between sugar consumption on the x-axis, country by country, and then the y-axis is the number of decay teeth, so it's showing you the correlation between the two variables. There's a linear correlation in there, a linear relationship, and they discovered that apparently 63% of adults read this chart correctly. The other 37% don't know how to read it. Now, I tend to be optimistic, and I believe that this is both bad news and good news. Now, it is bad news because 37% of people don't know how to read a scatter plot, right? And a scatter plot is not a new graphic form, right? It's not a super innovative way of representing data. The scatter plot, the first scatter plots were created by people like Sir Francis Galton in the 19th century. As you know, probably Galton was one of the first to define terms and principles in statistics such as regression and correlation. He was, for example, exploring the relationship between the height of a person and the size of the head of that person, and he created the first scatter plot. So this is a kind of graphic form that has been around for more than 150 years, and still 37% of people don't know how to read it. So that's the bad news. Now, the good news is that 63% of people know how to read it. That's also good news. Why is it good news? Because my guess is that if you had done this exact same survey 10 years ago, the results will be lower. Perhaps half of the population will know how to read it, and the other half will have no idea what they are looking at. Why is that? I believe, and this is all conjecture, I have not tested any of these, but I believe that it has to do to people like Hans Rosling, for example, who uses scatter plots all the time in his presentations, explaining how to read them. The position of the dot here represents that, the position of the dot on the y-axis represents that. That increases graphicacy among the general public, I believe. News media also has a responsibility in this increase that I conjecture that has happened, because news media has also started using sort of unusual graphic forms such as the scatter plot to inform the public. The first time that a normal common reader sees a scatter plot, they will probably be puzzled. What is this showing, right? But if you include a short caption underneath the scatter plot saying, this is how to read a scatter plot. The position on the x-axis, blah, 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 the position on the y-axis, blah, blah, blah. What you are doing is to increase graphicacy, to increase visual literacy. So I have not tested any of these, but I certainly believe, I have the hunch that has been the case, that there has been an increase in recent years of graphicacy among the general public. But we need to keep pushing, because graphics are still highly misleading for many, many people out there.
I'm being from Vietnam. I would like to thank you very much for your inspiring presentation. I have a question about the measurement. You mentioned about the four principles, good data, attractive, accurate, and accuracy. So in case I already had an infographic, how do I measure how is good data, how is incorrect, and how attractive, and how accuracy is?
I'm not hearing the question very well. So the question is about the accuracy?
About the measurement. That's when you already had in graphic, so how can you check whether your
whether things are measured well or not, how you can measure that? You cannot do that on your own. So none of us, I guess, is trained in statistics, right? So, or statistics or science, etc. And the use of statistics is also, it also depends on the domain. So statistics are used differently in many different domains. Therefore, this is going to be advice that all of you have received and probably all of you follow. But whenever I do graphics, whenever I do visualization, let's say a graphic about demographic patterns, I don't do it on my own. I don't just download the data and start representing things. I try to partner up with demographers and show them the data, and perhaps I explore the data myself and start spotting patterns and trends and interesting possible stories in the data, but I don't tell those stories directly. There is a step in between, which is that you show your assumptions, you show your exploration, you show the data that you're using to statisticians and quantitative scientists who know much more than you do about those data, and you ask them, is this true? What do you think about this? Am I getting things right? Or do you have any other ideas that I could implement or include in my infographic? So it's not something that we can do on our own. We shouldn't do it on our own, obviously. But we can take that first step alone, like, what is discounting? And reading the methodology, right, of all the research that we use, and then, just to ask questions later on to the sources, right? Do we have time for another one? Okay.
Thank you very much for this. I wanted to ask how effective it is to add text to graphs to try to add context. So, for example, in the murder graph you showed, if you had a call-out box next to the sudden spike that said, due to only a few cities, will people see that? Will people interpret the graph correctly?
Yeah. So let me try to be brief with that. In my classes and my books, I always say that visualization is not just about visualization. Visualization is not just about drawing, doing pictures. It is also about writing the right headline, writing the right intro, writing the right explainers, the right annotations. The wonderful people at the graphics desk at the New York Times have a specific term for that text portion of any visualization, they call it the annotation layer, which is absolutely necessary for any graphic. So writing and visualization go hand in hand. You cannot really separate them. Because what I was mentioning before, a chart on its own may mislead you if you don't really know what it is measuring, what it is showing, right? Adding text that talks about the limitations of the data, the caveats in the data, etc., is essential. Or a little caption, perhaps, that reinforces or highlights the message of the chart. It's part of the chart itself. It's not separated from the chart, right? So yeah, absolutely. Another one? Yeah.
Getting back to your thing about heavy metal bands, I was on a flight to Norway with some aging heavy metal rockers, one of whom kept asking his compatriots, where are we going? Bergen, we're going to Bergen. Oh, okay.
Bergen.
But one thing he said was, which was rather perceptive, was never believe everything you think. The correlation here is never believe everything you see. We're not only designing graphics, we're presented with data for stories about things we write about. Can you identify some quick, simple red flags that we should be looking for that would be misleading? And it, on the surface, looks pretty good, but is actually misleading.
So you mean features of graphics that may mislead the public when you represent the data, is what you mean?
Right. I mean, things we're confronted with that we should say, oh, there's a red flag, without obviously getting into the methodology of how the data was generated.
So
but this
beyond the data itself, which is the first step, obviously, for me, the most common kinds of misunderstanding when we read charts usually appear because of how things are measured along scales. So for instance, messing up with the scales is one of the most common ways of lying to the public. All right, so that's a huge red flag. So that's why it's so important to always take a look at the scales, the axes, reading what it is that they are measuring, making sure that the baselines that they are using for the graph are right. Another way happens in maps. I'm not going to get into the details, but when you see, for example, a map that uses different shades of color to represent the data, different intensities, for example, to represent different magnitudes of a variable, each one of these shades is called a class in cartography. And you can lie very effectively depending on how you classify the data. Right? So in my books, for example, I describe techniques to avoid lying to the public using different classes or classifying the data wrong or classifying the data in the right way. But then the most misunderstandings happen because of the principle that I explained before about seeing or reading too much into the chart, right? Inferring too much from the chart. And what I like to hammer all the time and remind people all the time is that a chart shows only what it shows and nothing else. You cannot infer, for example, correlation from causation. You cannot infer if you have two phenomena happening at the same time or consecutively. You cannot assume that the first one is the cause of the second one, even if it is shown in the chart. The chart will show that this happens before this happens, and our brain immediately establishes a causal connection between the two. That's the kind of thing that we need to curb. And we need to remind ourselves, well, the chart is only showing that this happened before this, but it doesn't really mean that both things are connected. So vaguely, those are the principles, or those are the things that mislead us the most, I think.
So it sounds like charts are sort of like what they say about statistics. Statistics is like bikinis. What they show is enticing. What they hide is vital. So.
It's not just about the statistics. It's something that happens, it's even broader than the statistics themselves. It's how the human brain works, right? It's like we like to see causality. We like to see connections in the world, right? Even if they are not really there, right? There is a book by Michael Shermer, I believe, who's titled The Believing Brain. And he talks about a phenomenon in the brain, a bias called patternicity, right? Visualization let us see patterns in the data, and those patterns are there. Those patterns are real. They are in the statistics, right? The statistics let those patterns, the visual representation of those statistics let the patterns rise up and become visible. It is our brain that establishes connections between those patterns. That is the dangerous step. It's not even the graphic itself. It's the interpretation that happens here that really matters. And that's what we need to control and learn about. Yeah. Another question? Oh, okay.
Hi, I enjoyed all your examples of how infographics can mislead us.
I'm not hearing you well, sorry.
Sorry, I'll speak up. I enjoyed all your examples of how infographics can be done less well. So I wanted to ask, do you have a favorite infographic? Is there something that you've created or seen that you thought just perfectly captured that information?
Sorry, let me approach you because I'm barely hearing it.
Of course, sorry.
So if I created what? It's not your problem, it's the sound here. So if I created what?
I was saying, do you have a favorite infographic that you've created or that you've seen that you feel really just perfectly captures that information?
Like historically?
Anywhere.
My favorite infographic ever? I can talk about that, yeah. It's not even a graphic that I created. I don't like my own graphics. Well, I like some of them, but not all. Most of them I don't. My favorite visualization ever, my favorite infographic ever, probably all of you are familiar with it, is Dr. Jon Snow's map of Jon, not the guy from Game of Thrones, okay? Actually, this is something that really pisses me off. Whenever I Google Jon Snow, Google tries to correct me. Do you mean Jon Snow? No, not that guy. So Jon Snow map. So this is my favorite visualization ever. The cholera outbreak map from 1854, not because of the map itself, but because of the story behind it, the entire process that led to the creation of that map. The map itself is just a black and white, ugly thing, but the entire process behind it, it's one of the most wonderful examples of data reporting ever. It's something that we can learn about as data reporters, right? So if you want to learn more about this map, there's a couple of books that I recommend. One of them is The Ghost Map. The Ghost Map, the story of London's most terrifying epidemic. That's a wonderful non-fiction book by Stephen Johnson. And then more technical, perhaps a little bit more technical, but also more accurate. It's not that Johnson's book is not accurate, obviously, but if you want to read more about the technical aspects of the map, there is a cartography book called Cartographies of Disease that describes early examples. I think that I made a mistake. Oh, scholarly articles. No, I don't want scholarly articles. I want the book. So Esri Press, Cartographies of Disease. This is a wonderful book that talks about ancient maps representing data. And it has a couple of chapters about Jon Snow's map and the ones that he created before and the entire process of the map. So that's my absolute favorite ever.
As a Brit, I'm very happy you chose a London example.
Thank you for the question. Okay, we need to, I will be around. Yeah, I'm going to just hang around over here, so if you have any other questions, just approach me. Thank you so much again. It was a pleasure.